Okay, noble gas configurations isn't like the most horrible concept, so I will go over it as simply as I possibly can. Feel free to ask questions if you need to. So, let me get my paper. I feel like this paper is one of the most helpful for explaining noble gas configurations because here you can see the entire noble gas row, right? They all end in P6 with the exception of, what is it? Helium, almost? Yeah, helium. So with the exception of helium, all of them end in P6, 2p6, 3p6, 4p6, etc. And it matches up with the periodic table that I have here. So we will use that very shortly. I feel like it's best to start off with an example. So like say we are trying to find, let's say nickel, for example, here. It's number 28. And the noble gas right before it is argon. So that's what we would use. I have no idea if it changes for nonmetals and transition metals, but I'm 90% sure that this rule is just universal, wherein you need to find a noble gas that is right before the element that you're looking for in order to shorten it. So in this case, let me get a pen. It would be brackets of, no, we're not doing ions. Yeah, you only need brackets when you're doing ions. No, you only need double brackets when you're doing ions. I forget here. Okay, yeah, you need brackets when you're referring to the element. So this would be bracket AR, and then since argon is, here, let me hold it side by side if I can, is 1, 2, did I forget how to count? Okay, it is 3p6 on my periodic table. So I feel like putting 3p6 is really helpful for me because I can really see like where I'm gonna go next to, and I feel like I have not actually explained this yet. So this part of the notes 10, I want to say, is where like I was going to start doing next, but I realized I didn't explain it yet. So here, this is a very familiar chart that we will have to memorize for the test because we are not getting this chart at all. Not like the periodic table. But it's not that hard to, what is it? I feel like all you need are just to memorize 1 through 7, and then that 7 is the max for these two, and these end at 6 and 5. And they just go by rows, the numbers, 1, 2, 3, 4, etc. So I feel like it's actually pretty easy to memorize. Like it's just way less overwhelming than you would think it is. But okay, back to my point. This paper, argon over here. So 3p6. 3p is right here. And next in the order is 4s. And let's see. Yeah. So as we know, the number of protons is usually equal to the number of electrons, and oftentimes on tests in the directions it'll say, please assume that the electrons are neutral unless stated otherwise. So unless it says ion, like bromide ion or something, then it's just going to be the same. Right now we'll pretend that it is neutral. So argon, I also like putting the number of electrons that I have because like my brain does not work in a very organized way, as you can tell by the video. So we have 18 and we're trying to get to 28 for nickel. Sorry, I don't think you can see. I think you can barely see. Okay, whatever. If we have 3p6 at the moment, then next in order would be 4s2. So that's what we would write. And then we would keep going on. So 3t10, that's 30 right now. And then, of course, next would be 4B. Oh, hell no. Never mind. I just went over. We need 28. So, of course, this will be AR4S2 3D8. Man, I can't believe I'm messing up on camera. And that wasn't even in the freaking frame. Okay, good. You guys didn't physically see my clownery. I hope at least you guys saw this when I was like directing this. Okay, whatever. I'm not even gonna edit this anyway. It's too much work. So this is the final answer. Yes, I printed out periodic just for this. If you have any questions, let me know because I can probably answer them. And I wasn't sure how I planned this video, but okay, yeah, I think that's it. I think I covered all bases.